My name is Jawad Saadi and I'm the Managing Director of Hexatronic Security. Today we're going to talk about the InOne solution from Hexatronic. The InOne solution is a powered fiber solution from Hexatronic. It's a hybrid infrastructure system that can be used for deploying devices out in the field, especially on long distances. The challenge that we are trying to solve, that when you deploy field devices, whether they are security equipment, CCTV, radars, or radio equipment, public Wi-Fi, 5G base stations, they all have something in common, that they both or all require power and data connectivity. The data connectivity is quite easy. There is many options with that, but the power is the challenging part because it's quite expensive and takes a lot of time to deploy. So typically, from the source of your power and fiber, you deploy AC power cables for the 230 volts AC and fiber optic cable. In the access cabinet, where you connect your devices and you have your industrial switch, you need to have an AC to DC PSU to provide power for the switch. That in turn provide power to the devices with PoE. So how have we solved this problem with the InOne solution? Let's look. We have moved this AC to DC PSU, we have moved it to the central point. So now we have the AC to DC here. What this will allow us, that we can have the DC power and the fiber optic in one hybrid cable that is carrying the DC power to the devices. So now we have gotten rid of the two infrastructure. We have gotten rid of the AC power cable, and that's a lot of saving and much faster implementation when we do that. Then we have to deal with another issue. What about the voltage losses on this hybrid cable? If I have DC power here, I will have some losses over the distance. What is required by the devices here, most industrial switches that are inside the access cabinet, they work on 48 volts DC or 53 volts DC. So we start with a higher power, and we start here in the AC to DC, we start with 110 volts DC. And the reason we picked that specific voltage is because the standards to have a touch-safe DC power and to have a non-certified or no need to have a certified electrician to install it, that it can be installed by telecom technicians or IT technicians, that it needs to be lower than 120 volts DC. So we have selected that at this point we have 110 volts. Then we can have a drop over the cable with the distances, and on the receiving end we regulate the voltage. But we're going to speak a lot more about that in the coming slides. Another dimension of the installation is a cross-section of the installation. In a traditional installation, you need power cable, you need duct for the power cable, and you need civil infrastructure. You also need fiber optic cable, a duct for the fiber optic, and another civil infrastructure, because most countries do not allow that you mix the power cables and the fiber optic cables in the same civil infrastructure. When you use the InOne solution, you only have one hybrid cable for both the power and the fiber optic. You have one microduct and one microtrench. Imagine how much faster it is and how much less expensive it is to deploy the InOne hybrid infrastructure. Let's talk more about the InOne hybrid cables. The hybrid cable, as you see in this picture, it's a micro cable. It has both copper for the power and fiber optic for the connectivity. They can also be deployed in traditional fiber optic microducts. The different sizes of the cables that we have, it varies between the area of the copper and the fiber count, and we have different variations of these cables. Let me give you a look with my head cam about the sizes of the cable. Here on the left side, I have three sizes of these cables. I can put the pen so you can see the dimension. The small cable, the medium, and the large, and it is different copper areas and different fiber counts. These cables, this is how they are in the traditional ducts. They can be blown exactly like fiber optic cables. You can have different ducts. This is a four-way direct buried duct. This is an aerial duct for suspended aerial installations. And this is an armored duct for submarine underwater installations. Let's go back to the slides. So how we deploy the system in a central node that we call the hybrid distribution node, where we have the AC power. We combine the DC power and the fiber optic. So this is the fiber optic and this is the DC power in one cable. Then we distribute this cable to access nodes in different locations of the network. And from the access node, we connect the devices. Let's take another level of details. What happens in the hybrid distribution node? In the hybrid distribution node, we place the UPS in a centralized location. So you need one UPS for your whole network that is connected to this node. We have the AC coming in from the UPS feeding 230 volts AC to the rectifier. Then we have from the rectifier, we take the 110 volts DC. Remember, we're using 110 volts DC. We feed it to the hybrid ODF. Then we have the fiber optic coming into the hybrid ODF. In the hybrid ODF, we're combining the DC voltage and the fiber optic, and we go out with the fiber optic and the power on one cable, which is the InOne cable, until we reach the access node. So what happens in the access node? We have the InOne cable coming in here, and we have both the power and the fiber. We take the power to the power card, because now we have a floating voltage over the distance. The voltage have dropped. So if we're 2 kilometers away with this access node, maybe the voltage here is around 100 volts. It dropped from 110 to 100 volts, let's assume. And so we need to regulate this voltage, because the industrial switches, they work on 48 volts DC or 53 volts. So we regulate the voltage, and there is a voltage regulator inside this power card. And we have the regulated voltage coming out from the power card to feed the industrial switch, or you can feed the devices directly if they require that. The fiber optic, we have the fiber optic coming from here to the splice cassette. From the splice cassette, we splice fiber in to the industrial switch and fiber out to feed the next cabinet. The ducts we mentioned, we have different kinds of ducts, and we have wide variety. If you have a specific installation, speak to us and we can advise you on which ducts you use. Another very interesting aspect with the InOne, that we have extremely flexible network topology. We can support any network topology. So in this example, you have your devices in a daisy chain. So you go from one cabinet to the other and you connect them. In this example, you're fanning out. So here we're fanning out to 2 routes. Again, at this point, we're fanning out to 2 other routes. And in this example, we're fanning out to 3 other routes. You can add a fan out at any time. So you can splice the cable and fan out from it, or extend more devices. The other interesting aspect, that you can connect your devices in a ring topology, and on the left side you can see the ring topology, and this is exactly the same reason why you connect ring topology in fiber optic networks. That if you have a cable cut, so let's assume that I have a cable cut in this location. So now these 2 cabinets on the right side, I can feed this cabinet and this cabinet from this side of the ring, and the other 4 cabinets on the other side of the ring. The voltage, the power supply has a current limiter, so it detects if there is any short on the cable, it drops the voltage. But when that short ceases to exist, it re-establishes the power. So during the cut, there is very minimal interruption of the power, but the power gets re-established immediately. Another interesting tool that we have created our design tool for the InOne that we can share with our partners. You don't need a heavy consultancy job to calculate the power. You can use the tool to calculate how you deploy the devices. It considers the power budget, the network topology, the distances, the device loads, the network losses, considering the cable types, and you can change these things until you get the right design of your network. We can either do the design for you or share the design tool with our partners, and they can do the design after they receive the training to their customers. So let's try to conclude with the major benefits. Redundancy, it's a big deal. Security or public Wi-Fi or 5G are critical applications. Redundancy is extremely important. Whether you deploy your devices in a ring topology to have redundancy against cable cuts, or you have the UPS to have redundancy against power failure, or you put duplicated PSUs to have redundancy against hardware failure. Redundancy is extremely important, especially in critical applications. Security. And we mean here by the security of the power. In many cases, customers do compromises with the power infrastructure. Because it is so expensive and difficult to have AC power out in the field, sometimes they look where is the closest power, and they borrow power from a light pole or a pump station or a guardhouse. The problem with that power is not secure. Other electricians have access to that network. They might shut down the power for maintenance reasons or any other reasons. It could be hostile reasons as well. You don't want that. You're going to deploy the fiber optic cables anyhow. Why not deploy the power along with your fiber optic cable and have your power secure? It's your own power coming out from your own UPS, coming out from your own backup systems. That is extremely important. Speed of deployment. After you have seen how we have the hybrid power cables and the hybrid system, it's very obvious that this is a much faster installation. If you need one civil network, one civil infrastructure instead of two, if you need one cable instead of two, if you're using micro cables, smaller cables, then it's faster to deploy, faster to transport. Everything becomes faster, and that is extremely obvious. Then in critical applications, it's very important to monitor your network and get alarmed for faults. What we have done with the InOne solution, and we have a special presentation for that, we have put sensors inside the access cabinets and the distribution cabinets, and then we can see, we can give you an alarm if there is a cable cut, if there is low voltage, or if there is over temperature in the cabinets. And these alarms, you can read them as it is, or you can bring them into your own VMS system or PSIM system or any other alarm system in many different integration ways, but you need to see that special presentation to know all about the details. Flexibility. Since we can support any network topology that is flexible, so we follow your network topology. Maybe you have some existing ducts. We just follow the routes that you have. Or you have barriers that you cannot follow a certain route, then we follow the best route that you have or the most economical route. It's very important. Some other solutions are limited to point-to-point, which give them point-to-point and star topology, but they cannot do daisy chain, they cannot do ring, they cannot do fan-out. So we believe that this is an extreme advantage to have that flexibility. Environmental, and that's extremely important. When you're using micro cables, there is so much less material used, much less polymers, much less copper, and that's a very big saving for the CO2 emissions. Also, when the cables are much smaller and much less, it's less transportation cost and less pollution due to transportation. And when they are smaller and you have one civil infrastructure, then they require much less machinery when you're installing, when you're doing one civil work instead of two. So the environmental saving is extremely obvious as well and extremely important. Last but not least, and very dear to all our customers, is the potential cost saving. When you're doing one civil network instead of two, when you're using smaller cables and less copper, less devices, the saving can be very obvious. The saving varies from one project to the other, and the biggest factor is the civil network cost. The more expensive the civil network in that area, like city centers or places with very hard topologies, then the saving will be more. But in every case, I could say that there will be a kind of saving. So these are the benefits. Each one of these on its own is important enough for a customer, and each customer values different benefits differently. So what can you use the InOne for? I don't have a complete list. Any device that you want to deploy out in the field can be connected to the InOne solution. But from our existing customers, we have a lot with security, CCTV or radar, siren systems, IoT gateways like LoRaWAN gateways, public Wi-Fi access points, or 5G microsites, microwave mini links, radios for fixed wireless broadband. I mean, there is no complete list of devices. But what you will get also, you will get links for dedicated videos, one for each application, where we can dig into more details about each one of these applications. So look in the description below for the links for these videos per each application. You can look you can look for more information on our landing page, hexatronic.com/InOne, or you can use this link that we'll also have in the description below, where you can book a dedicated online demo for this. We also have a video with a hands-on presentation about the InOne solution, and we will have a link for that as well. Thank you very much for attending this presentation. Contact us at inone@hexatronic.com. Let us help you design your networks, compare the InOne with the traditional installations, and we look forward to hear from you. Thank you.